So this time the learning outcomes are the right way around, and we start with the definition of power. There's a few different ways of expressing it. I think this is probably the clearest, but we'll put the other ones in case you come across them as well. Power is the energy transferred per second. And as we'll see, the formula helps reinforce that definition as well. You'll also hear it expressed as the work done per second, or, because remember work done just means the energy transferred, the rate of energy transfer or the rate of work done. And in general terms in physics, a rate means something per unit of time. So usually per second, or it could be per hour. So speed is distance, is the rate of change of distance. So it's the distance per second or the distance per hour. And so on. You'll come across various definitions like that. You only need to learn one of them, whichever one feels most comfortable for you. And like I say, the formula then reinforces that. So you can use the formula sheets when you're asked for word definitions for concepts like power. You can use the formula sheet. You see it's E over T, so it's energy divided by time. It's the energy per second is what you're working out there. So P is power, and we introduced the units are watts. E is energy, standard unit there is joules, and T is time measured in seconds. So a simple example to start with. So a cyclist uses 1200 kilojoules of energy in a time of 2 hours. Calculate our average power. So we're going to assume the power stays roughly constant to get this idea of average. So, although it's a straightforward use of the formula here, I've picked some units that need a wee bit of conversion, so we should do that as we're listing variables. So, multiply by 1000 to get into joules. And the time is 2 hours. Which is 7,200 seconds. I'll just put my work underneath this time. So we're being asked to power. So our formula is P equals E over T. 1,200,000 divided by 7,200. And just straightforward calculation. And my calculator is displaying 166.666, etc. But if we're rounding to 3 significant figures, don't forget those 6s would round up to a 7, and we get 167 watts average power. I'll do one more example, but this time rearranging the formula, and in particular trying to work at a time, because that's the most complicated of them, because it's on the bottom line when you're trying to work it out. So example 2. So a motor has a power of 500 watts. How long will it take a lift? Sorry, how long will it take to lift a crate so that it has 240,000 joules of potential energy. So once again, standard problem solving techniques, list what you're told in the question. So first thing we come across is a power, and then we've got an energy. Now it doesn't matter in the power formula which energy you've got. So whether you're expressing it in terms of work done per second, right, kinetic energy per second, gravitational potential like this question per second. And the question says how long will it take? So we can translate as we're being asked the time. So the formula, as it's given in the formula sheet, and watch, I think this one in speed, distance, time, for some reason are the two I think that people mix up most, so always check it in the formula sheet. And then always do your substitution before you do any rearranging. So now we've got a bit of rearranging to do, and the first problem I've got is that t is in the bottom line. So the first thing I'm going to do is multiply both sides by t so that it cancels out that divided by t, the t in the bottom line on the right hand side. So I get 500 times t on the left hand side, and the t's on the right hand side cancel out. That's why we're doing it. And now I can divide both sides by 500. So it does involve 2 steps to get to the answer. That cancels down to t on the left hand side, and you get the calculator out, and you get 460 seconds. Is your final answer there. Not the fastest lift in the world. 6 minutes to lift this up, but okay, it gives us an idea of the calculations involved.